Welcome to this particular session, and in this video we're going to be building a machine learning model that basically knows how to predict an individual with complicated malaria, so more like a malaria prediction pipeline. Okay, so yeah, that's what we're going to be building, and we're going to be training with two models. And yeah, definitely we'll save our model, and then yeah, we can actually deploy it for some testing. But for the sake of this video, I'm just going to show you out some of the things we're going to do. We import some libraries, then we run our data set around it, and yeah, we'll get started. So to start, I've already selected my kernel here as Python 3.13.3, and I already saved my file as a Malaria Interactive Python notebook. Okay, so I'm going to open the code. I'm going to import NumPy as NP. I'm going to import pandas as PD. I'm going to import matplotlib.pyplot as plt. I'm going to import joblib. I'm going to use it to save my model. And then next I'm going to do is I'm going to import categorical encoders as CE. Now from Scikit-learn.com, I'm going to import ColumnTransformer from Scikit-learn.model selection. I'm going to import Trenta splits. I'm going to import cross validate and skfold from Scikit-learn. Accuracy score. Maybe I can actually import classification report from Scikit-learn. What else will I want to need? I'm going to just go to linear model. I'm going to put logistic regression. I'm going to import random forest transform. I think this is actually important. And probably from my metrics, I might want to add. Okay, I'm just going there. Okay, I could just say preprocessing, import one hot encoder, ordinary encoder, and probably standard scalar. I think those are actually enough for what I'm going to be performing right now. So now to get started, I'm going to just create a random variable. I'm going to call this RNG. Let's go np.random.default ring. I'm going to set it at 56. Records, I'm just going to create a records, an empty list. 1000 data sets, and then I'm going to say record, an empty dictionary. So I'm going to call this age. So I'm going to say RNG dot integers, then age is going to be from 10 to 91. Okay. Now I just have some things in mind, hemoglobin level, for us to make some of those prediction. Okay, so I'm going to have to be sure that's it. Okay. So what's going to be RNG.int. Now to be sure, what's the range of hemoglobin level? Okay, I could say 10 point something. Some of them are in decimal, so we could say uniform, and we can set it from 10 to maybe 20. Okay. Okay, so we can take parasite density. Okay, and yeah, those actually. I'm just going to assume this is okay, maybe age all in uppercase. Okay, I'm just going to make it a bit messy data, and temperature. I could say from 100 to 10,000. Temperature has dash, and RNG that's uniform. That's going to be from 32 to maybe 40. Okay. And the next thing we're going to have there is categorical as sex. So say sex is going to be at maybe let's assume there is a space and it was filled in, and okay, so that works well. rng.choice, and then we're gonna have a list, and that inside of that list we can have female, male, female, female, male, okay, and maybe inside of it we'll have none. Okay. Now you notice we have several categories of female, so we're assuming that this is a kind of a messy data set. Looking at how people filled that data set, okay? And then the next one we're going to have right now is region, okay? I'm going to leave it in capital. I'm going to say rng that. I'm just going to apply the comma there. Choice. And I have Abia, we have Imo, we have Taraba, we have Bauchi, we have Jos, we have Owerri, we have Ogun, we have Lagos, we have Abuja, Maraba, okay, Maraba. Then the next one is going to be hospital type, okay. Now let's leave a space here, okay. If you watch, you see that there is a space, and we're going to say rng.choice, and that's what we're going to say private. Then we'll say tertiary community, and we can just, maybe we could just add another thing. They will say clinic. Okay, I think we can just take out this community, and let's leave it there. Okay, now let's assume we have another thing of maybe education now level, okay. And all we're going to do now is say rng.choice, and then we're going to see none, tertiary, then we'll have primary, and we'll have secondary, okay. Then what else we could add? Okay, we could see bednet use, okay. So we'll see here bednet, use, and I'll have rng.choice. Oh yes, no, I think that's fine. And so next what we're going to do now is we're going to say records.append. So I'll put our record, okay. So if we try to print records, so basically this is what it's going to give us. So it's going to just give us a kind of a list of dictionaries. What did it say? Choice P. Okay, that's it. And okay, that's correct. So now it's going to give us kind of a list of dictionaries, and yeah. So what are we going to do now next? So we can just create a function. We can try to create a function. We can call this function create data frame. Okay, let me just. And now this function is going to take in. It's going to take in records, and inside of it, we're going to see what we can use. You can say malaria df is going to be equal to. First of all, I want to check something. It's not defined, just to be sure that we don't have that, okay. So we'll see it's going to take in records,
then that's going to be pd dot data frame. Inside of it, it's going to be records that it's going to take and return. It's going to return malaria df. So that works fine. And for us to get our data frame, so we can just say we can call it create data frame, then we'll pass in our records equals to records, and that's fine. So this is it. It works clearly. And now what we can do now is I can assign this now as our df to be this. That means that if we say df, automatically it will give us this. That's a very, very good way. So since we already have our df, so what we can do right now is we might want to create our target column. So all of these are what we call features. Okay, these are some of the predictors that we use in getting our predicted. Okay, so what we're going to do right now with respect to that is that we can actually use our sigmoid function, and where we can say that if the temperature is reducing and if the temperature is increasing, there is increased risk of malaria, and if hemoglobin is also increasing or probably decreasing, there is an increased risk of malaria, and then maybe bed nets is equals to 1, then it means that it reduces it. So let's create that ASAP. Now what we're going to do right now, we're going to say risk. Now our risk is going to be, now remember we want to use the sigmoid function, and to use that function, so how do we actually initiate our risk now? First of all, we see that for our 0.02, that is if it increases by 0.02, this is 0.02 times df of that's going to be df of maybe hemoglobin level. I'm just going to copy that. And then plus 0.03. Now it's going to, that means that if it's increasing, right? Okay, parasite density, no, we're not going to use that. So let's use bed nest. Okay, we're going to plus, so df of bed nest is. So I'm just going to copy this just as it is because we've not cleaned that. Okay, and so for bed nest use here, it's going to be, it's going to be bed nest use equal to yes, and as type int. Okay, so I'm just gonna, let me bring this down. Okay, so now we could just print our probability. Now how do we actually get our probability? So we want to use this logistic function, so we're going to use the logistic function, okay, which is known as the sigmoid. Just do the sigmoid function. So I'm just going to show you what this function looks like. So this is just it. So this is what this function looks like. Okay, that's the how can call it, the sigmoid. So basically what this function does is that it returns 1 or 0. That's like it tries to return values that are between the range of 1 and 0. I'm just going to use that. Okay, so let me just say returns values within 2, 1. All right. Yep. So I don't need to save that. I just wanted to just say that. So I'm going to say 1 plus np dot exponential. So that's numpy, and inside of it we'll have our minus. So what's going to be our r? So we'll say our risk minus 3.5. Okay. And then let me just try, just to be sure everything works perfectly. Raised to the power minus risk minus 3.5. I think everything works fine. and okay, missed one comma there. So I can just try to print, but I'm just going to show you another way we can do this. Okay, that works very well. Okay, that really works so much well. And I could decide to change this to 1.5. It still works fine. I can decide to change this to 0.5. That's still cool. Or I can decide to, change this to 0.4. And yeah, that works well. Okay, cool. Now, what we're going to do right now, so it's more like relatively the range, whereas this, so I can decide to actually alter this and say 1. And yeah, it still works. I can decide to say I can decide to put maybe 2 here, and yeah, that works fine. So basically I can change it how I want. I can just put 0.1, and you see that still works. I think I'm just going to change that to 0.0. It works fine still. I could put maybe 3, and yeah, so these are just basically more like between the range of 0 to 1. I'm just going to explain that very well. I could do 0.05, and you could just see the ranges, and yeah, so yeah, so that's actually it. And yeah, so you can try to add another variable. So basically what this risk is saying that there is an increased if there is a bed nest is 0. If there is no bed nest, there is an increased risk plus of malaria, and hemoglobin dropping can increase the risk. So I just can actually set changes to plus again here, and yeah, so that is just it. That's just me playing around with the values and all of that. Okay, so I can just keep this at 0.9. I think that's a very good score for me. Now what we're going to do now is there's also another way for us to do this. We can try to use the ternary operator, to make some kind of argument and all of that. And I think I'm just going to show you that also in HV. But then let's complete this now. So what we're going to have here now is I'm now going to say for me to get, remember we're looking for our DF for malaria positive. Okay, that's what we're looking for, because here basically we have all these are our features, and we've not got our target. So what we can do here now is that this is now going to be equals to rng dot, I think I can wrap this rng dot choice, and no, I'm just going to use the uniform. Okay, so I'm going to set that 0 to 1. If it is greater than probs, let it return that for me, and type maybe int. So if I do df, I could see that, right? And if I say if it's greater, I'm so definitely going to get some values. I could do df dot tell, maybe 45. Let's see. Oh, it's very, 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 very tight. Okay, so this is just like one approach. So it's very tight. So what I'm going to do right now is I can decide. Okay, I think there's a missing parameter. Sure. And so size equals to 1000. Wow, so it throws up an error. Sorry about that. And what we can do right now is okay, sorry, I'm just going to take this out. So what we can do now is we're going to use this is one approach. Okay, this is one approach that we can use, the logistic function. And then I'm just going to use something some of you might be very, very familiar with and easier for you to do. So what I'm going to do right now is I'm going to say create a function. I'm going to create another function. I'm going to call the function estimate malaria positives. Okay, now let this function now take in some parameters. It's going to take in bed. It's going to first of all let's start in an order. Hemoglobin, and then it's also going to take in bed. I think that's okay. Yeah, so now what we're going to say is we're going to use a ternary operator. I'm going to say return 1 if. Now what is the if? Now the if now is going to be if hemoglobin is that's if it is
greater than. Now we'll just check our data set here. We'll have hemoglobin between its range, so uniform. So let's see if it is greater than maybe 14.5. I think that reduction is, as you can see, it's less than maybe 14.5, and bed is equal to no. Now let's also add S0. Okay. Now let's add excuse me. Let's see if we can add some other arguments that might be relevant. Temperature. We can actually add temperature here. Temperature. I'm just putting in the correct order. Temperature. And I can't see temperature is greater than or equal to 37.5. Okay, that works very well. And so how do we now call this function? So we're going to say the df for malaria positive, because that's what we're using as our predictor. If I can spell that correctly, malaria positive is going to be we're gonna see what are we gonna say with df dot apply. So what are we gonna apply there? So definitely we're gonna apply that function, and for us to call that, let's just create a lambda function, and I will say estimate that. Okay, and so we're gonna say the risk. So for the first row is gonna be hemoglobin. So we check our data set and we confirm that's what we actually imputed there. So we're going to shift this. So the next one is going to be temperature. So you make sure that temperature aligns with what you imputed. Okay. So I'm just going to put that inside of here. And then the next one is going to be bed. I think that works fine. Maybe you don't need to forget that this works in the axis of 1, which is coming down. Okay. And with that, I think we're sure. Say df, let's view that. Okay, cool, that's very, very wonderful. So this is our data frame, and you can see there's a positive malaria case there. We can say df.head, and maybe let's do 19. So this is it. Okay. What we can do now is if we want to understand how many positives that are there, sorry, hold on, you can just do df malaria positive dot value. Okay, cool. So we have 67 positives and 933 negatives. I think we are good to go. So the next part of it is we're actually working with the with an outline is for us to inject 20 missing values. Okay, so I'm just going to copy this. Okay, and I'm going to come back here and add this in the markdown. So for us to inject 20 missing values, I'm just going to write all up, inject so what we can do now is df.log, and then we'll have, now there are actually several ways we can do this. Okay, first of all, we can decide to see our column again, df.column, so that we can be seeing it closely, and we can say df.log, and basically we can go by fraction. Okay, inserting in a fraction of the data set, but then I'm not going to use that approach, so let us just more like have a much more clearer view of what we are doing. Df.index, and the size is going to be 20, and this is just if we want to do for 1, and it's going to replace false, and so this is going to be for our maybe for our age, right? And basically when we do this, that means that 20 values in our age has been replaced now. But this might be a very stressful manner. What we can do is that we can just copy all of this
instead of just doing it that way for age, or maybe we can just like create calls, call it columns. I'll append them in a list, right? And maybe I can just take out 2 that I don't want to add, right? And so I'm just gonna comment out. Okay, since we've done for age already, let's leave this for age. And okay, missing values we complete it by saying none, or we can say np.none. Okay, that means what's the problem? Can have some function call equal to this. Oh, sorry, that's our mistake there. We didn't use the block. Okay, so that works fine. Now, since we've actually created this ternary, this particular list, so we can now say for we can say for call in calls, and we say df the lock, right? That's to locate that, and yeah, we're also gonna ring that choice, and then instead of df.index size is equals to 20, and that replace is equals to false, and we have our call. Okay, okay, so that works well, and nothing happens. So it means that 20 of this column, we need to now still assign it maybe to none, and that's fine. So it means that inside of this particular column, we've looped around it and we've assigned them to none. So we can just check out that by using some kind of df, and you see some none are actually floating, yeah, around it. Okay, I'm just regenerating that. Okay, so you can see that. And another thing that we're going to do right now is since we've added that, so now let's add some kind of outliers. Okay, so what do you mean by outliers? Outliers are, most times when you want to kind of make a description of your numeric data, and you're having values that are abstract. Let's say, for example, you have a data set and you're seeing age, you're seeing ages of 91, 34, and you're seeing an age of 537. In that case, that's an outlier. Okay, and how do we handle outliers? We handle that by clipping, but then we're definitely going to inject some outliers into this data set, and probably we're going to do that on our hemoglobin. Okay, and to do that, we're not going to use a for loop for it. Easy to do, but maybe let's just do that for temperature, maybe hemoglobin and temperature. Okay, so I'm going to do that by saying df.log and df.log, and then I'm going to do what next? I'm going to say okay. Yes, I'm just going to pass in this block dot choice, and inside of this df.index, and I'm going to set the size at maybe 9 outliers, and inside there I'm going to replace as false. Now this time around is going to be our hemoglobin level. Okay, and I could just say 992. All right, so probably there are chances that whoever filled these data sets might have made some mistakes inside of it. Rank dot choice df.index size is equal to maybe 18 outliers. So we'll go here for temperature. I'm just going to say false. I'm just going to copy maybe this is going to be 108.4. That's the outlier, okay, because this is above human temperature. So those are actually the important parameters that we need to get. We've inserted some messy outliers, 5 outliers. Okay, let's go again. df.log rng.choice and df.index, and I'll say size of 5, and I'm going to replace equal to false, and this time around is going to be in parasite.
Okay, and maybe we're having something like 23. Okay, so these are more than 5 outliers, and I've done it to several data sets and some of the features components there. So what we're going to do right now is I'm going to just kind of what I'm going to do right now is I'm going to kind of start up the cleaning of this information. But before that, let's create some kind of duplicate. Okay. And there's a reason why I want to run this in a new terminal so that you're going to understand some things. And then for us to create some kind of duplicate, there's actually some important information that we need to have, on the course of creating a very suitable duplicate. And so I could just say that if duplicate, maybe if duplicate, maybe let's just create the duplicates. Normally, I'm going to say df is now equals to maybe pd dot concat. Then I have df I will a sample of 10, take note, and then we have random state of 89. And probably we might ask it to ignore the index to true axis 0. Okay, because it's on the row. Okay. Now what is going to happen is that when I print df, watch 110. I see. Now if I mistakenly run this again, it has added another 10, 20 now. If I run it again, it has added another 10, 30. And that's what it will continue to do if I try to regenerate this. Now, but basically, how do we control this? Now, the way we're going to control our data from not growing is that I'm just going to restart this kernel. I'm going to restart it. And yeah, I'm just going to tell you the reason why I did that. And because I restarted that, I'm just going to run this first one. I'm going to run this. So df choice is not defined. Now what I'm going to do now is I'm going to take out this. I think it's still the kernel still remembers that. I'll restart it again. Just going to wait some seconds. Okay. Okay, so now watch, if I say df, it gives me back my original data set. Okay. Now, but how do I add duplicates without not letting it grow? I'm going to say that if maybe something like like duplicate. Okay, duplicate added, not in globals. Now, what's global? Globals is just like a method. It's a method. It's a kind of method that we have in Python. So this is why I can now run my pd.concat. Okay, I'm going to say, pass my df.sample. And inside of it, I'll have 10. Because we're just trying to create some duplicates, right? Random state of maybe 9. And I could still ask it to ignore the index. Now what I'm going to say is that duplicated added is equals to true. Now if what this means now is that if I say df, it's going to give me 110. Now even if I run this again and again, it cannot let my data set grow. Okay, so that is very important. So we've added the duplicate. So guys, basically we've done everything. We've added duplicates. We have messy columns. You can also see it here. We have more than 5 outliers. We have wrong types. Just to be sure, if we added any wrong type, maybe we can just maybe just randomly add something of unknown. We can say df.log. We say rng.choice df.index, and then we have our size as maybe size at maybe 17 and replace false. Or maybe where can we add this? We can add it in hospital type. All right, and yeah, we can just say this is what unknown. So run that, and when we run this, so when you look at hospital type, where is it? That's unique. So we have so value. Okay, that means that hasn't entered. All right, so I think there are changes here now, and we can. So if we try to change this to maybe city, something will apply there. So what is actually some kind of messy data type? That we can actually get from our data set. And yeah, so basically we can just yeah, ride with that. And okay, so I'm just going to okay, so I could see here dot head. So I'm just going to print some df. That's clear. See, yeah, just for us to have a clear grasp. Okay. Oh, he added another column called hospital type. Oh, I just got the gist now. I was just checking that out. And yeah, so we can just restart our kernel. Just restart it. Okay. Because the next thing we're going to do now is to convert okay, so yeah, so let's restart our kernel. Everything runs so well. Beautiful. So we now have our hospital type, and if we do df of hospital type dot maybe unique, okay, and we could say value count. Perfect. So we now have unknown. We've injected unknown, okay, inside there. I think it would be very nice to spell that correctly, and we'll still restart our kernel so that okay. All right, so the next thing we're going to do now is we now need to start our data cleaning. All right. So we need to start our data cleaning, And the first thing we'll start with now is to adjust the messy columns, okay? So that we'll have a better column, okay? And now how do we do that? So there are several ways we can do that. First way is that we can start to say df is equals to df. Maybe we can say df dot columns, or is equals to df dot columns. Then we now some kind of string. You perform some stringing. But I think there are some data sets there that we need to. There are some columns that we need to replace. Okay, and we can say rename, whichever one. So we say df is equals to df dot replace, and maybe I'm just going to show us what the columns looks like, so that we can have a much more visual. I can just say df dot columns, and so that we'll not make any mistake. Okay. So here we can actually replace. What can we replace? We can replace maybe age with age, and let's see if that works. Okay. I think what we need to do, can use rename. Df is equals to df dot rename. So columns of age will now be renamed as age. That works perfect. So you can see that age now has been renamed as age. So we can also add another one. So we don't like what we saw with temperature. So we just come here and say, okay. I can try to copy it from here. Excuse me. I want to rename that to okay. Automatically it has renamed. So but we have some spaces here, and we have some spaces here and all of that. So what we can do here now is, if we do df dot columns, you said there's now an update. Okay, good. So what we can now do next is we can now say, okay, df dot, remember that there are still duplicates inside this one. But the first step that we are doing in cleaning our data is by adjusting our columns properly. Okay, so can you say df dot columns is equals to, maybe we can say df dot columns dot, now what can we say? We can say now dot string dot strip. Okay, so what does dot strip does? What does strip does is that it removes what? Spaces. Take for example, look at sex. You see that there's a space there. Okay, so what does strip will do is to do what? Remove those what? That space that is there. This is something that is common in someone that is filling a questionnaire. Now dot string dot lower. So what does dot lower does is that it converts everything into what? Lowercase, and then going to have dot string dot what? Now this is going to be replace. Okay, now but what are we now replacing? We're replacing any space with this, with underscore. Okay, so we can also replace, maybe we can still do it again. Let's assume this now. I wanted to replace it, because still maybe put something like that ends with this or something, then I'll replace it. But this is fine. Okay, so this is any space in the string. Let's say now we're writing, for example, here hospital space, it has to replace it. Educational level space, it has to replace it. Business space here, space here. So to add underscore in it, and that's how we'll now get that's basically how we're going to now get a more cleaner data set. So if I now say df, so you see that all of this now has a space. Dot lower, what it does is that what? It converts all of this into what? Lowercase. If I use dot upper, guess what happened? It will convert everything into what? Uppercase. Okay, but I'm just going to change it to dot lower. Okay, all right. So we have now cleaned up our data frame. And the next thing we're going to do now after that, I'm just going to remove this. So next thing we're going to do with that now, we're now going to change our numerical. I'm just going to print that again. Let me just print that df again so I can have a look at it again. So the next thing I'm going to do is I'm going to now change everything in this column into, I'm just seeing something here, parcel density. I think we misspelled something along the line. And okay, that was here. We'll run that again. That goes out, disappears. Okay, so that's clear. And the next thing we're going to do now is we'll look at our data set. Everything still looks okay, but we'll still have some norm here. Okay, and we have some some kind of messy stuff inside of our data set. We have outliers and all of that. So how do we handle outliers? How do we even know if there are outliers? That's one of the questions in machine learning, because it's not about showing you how to take it off. You need to know how to understand that. Now, usually outliers are associated with numerical variables, right? I remember in our first lecture we talked about how to handle numerical variables, and how to know which of them is a numerical variable. So we're going to actually say df dot maybe we'll say unique, basically dot columns. Okay, and also these are now our columns now, right? Now, first of all, let us define our columns now in order, so we can be able to check them one by one. Now, for age here, I will say df age dot, maybe we'll say dot what, describe. Now, what it's going to bring to us now is going to show us distribution in the age group. Now, using our intuition, now we know that age here is max is 90 and 51. Okay, they are all within the range. You're looking at our 75% quartile, range is 71. 25% quartile is 32. So that's fine. I don't think there's any outlier here. Okay, another way that we can actually show or demonstrate outlier is that we can use a box plot. So we can say plot dot figure. Remember, we imported matplot lib, say plot dot box plot, and then inside of box plot we can pass in our maybe age. Okay, we can pass in our age or something, and then probably when we run our plot xy and all of that, it's going to display plot for us, maybe something of something. I'm just giving an example. This is just an example of what we can see. Sorry, I don't know, that plot just disappeared. Okay, so that's just like a second approach how we can use it, understanding the outliers. Now, I'm going to also do some more videos about that, okay, but I just want to keep this very simple. Now, so we check for age. Now, we didn't find. The next thing we can check for what? We check for hemoglobin level. Okay, and we dot describe. And when we run this, okay, I think there's a mistake in the spelling. We didn't spell properly. I'm just going to copy this just to be sure we edited that. Okay, so now when we look at this distribution here, it shows that clearly there are outliers. And how do we know? Now look at this now. You see the minimum is 10 point something. The 25% quartile is 12 point something. 50% quartile range is 15. 75% is this, and then the max is 99. That's much. So what we'll do now is we'll clip it. Okay. So we're going to clip it. So this is what basically we're going to do to our numerical variables. We're not going to do it to sex. There's something like categorical outlier. Okay. Although in life, human beings, there are some human beings that are categorical outliers. So here we can just say, okay, parasite density dot describe, and okay, you see that mean is 23.00, and then 25% quartile is this, and this shows that there is still what, an outlier. So when we check, when we assign that, I just want to be sure. Parasite density, okay, that's that 23. There's an outlier. So more like using your brain, you say, okay, how can we be having 24,000? Here we have 4,772. We have 7,720, and then we're now having 23. That's very low. So you see the outlier can be high and also be low. So that's also what, an outlier. Okay, so it's very, 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 very important that we understand all of these, and we're going to clip them one by one. So the last one we're going to check for now is temperature. Okay, so we're going to do df dot, we're going to say df okay, I think that gave us the complete spelling, and then we look at this again. Look at the 25%. This is the minimum,
This is the 50%. This is it. And the maximum, we're having 108. Whereas this is the range that aligns with the what? With the minimum or the mean. Look at the mean. Look at the range. The 25 to 75% interquartile range. And then we're having a maximum of 108. So it means that still that is what? An outlier. So there are a lot of outliers there. So we check for age. I'm sure that was the first thing we did, and we found no outlier because the mean, look at the distribution, 32, and then we have some kind of mean of 10. Okay, so people can be 10 years old. That's fine. Max is 90. So that's the distribution. Okay, so what we can now do right now is we can now say, okay, now let's have our df now to clip that. So to clip, that's for us to clip those outliers. Okay, what we're going to do now is I'm just going to clip it beneath where it was described. So I'm just going to say here df dot age, that is equals to going to be df. Okay, now watch, dot age dot clip. Okay, now the clip method takes in two parameters. Okay, it takes in lower and upper. So lower is going to be equal to for age. Remember, we don't have any outlier for age, so I don't think there's any need for that. I was just giving an example. And then for hemoglobin, we're gonna have just gonna copy this. Excuse me. It's gonna be equals to df. I'm gonna copy that again. Now that's clip. So we're gonna clip it between two boundaries. The lower boundary is going to be maybe we could say the mean is 10, so we can clip the mean at 10.0, and then the upper we can clip it at maybe 20. Okay, just basically using the range. Or let me just say 19.0. This is just for the outliers. Okay, so say df maybe hemoglobin. Oh, what's the problem? Okay, I didn't spell that correctly. I forgot to put level. All right, so if we do that, so you see that if we try to do the describe again, you see that there is no longer any outlier. Everything now is now in the region. Now, what it might have done now is that some of them that we had 20, it reduced it. So let's just put that back at 20. And okay, well, none of them came true as less than 20. So you see that these are actually the outlier. There is no longer any outlier there. So the same thing will happen for parasite density. I'm just going to copy this. Remember, we're trying to remove outliers. I'm just going to write in comments. I already taught you how to do comments. This is for check for outliers. Okay, just going to put this again. I'm going to call this check for outlier. Okay, so for this I'm just going to paste this here, and I think I'm going to do away with this. I'm going to dot clip, and the lower is going to be okay, we can just use the mean 23 point no, we're going to use this, the 25% quartile range, and the upper is going to be, we use the 75% quartile range for that. Okay, and then let's check it out. Now you see that there is no longer any outlier. Okay, everything now is now in range. So the last one we're going to do now is removing outlier for temperature. Remember, repetition is going to make us perfect. Removing temperature outlier, and then that's what we're going to say. So here we're going to use the clip method, and our lower is going to be, we use the 25%. So you can start to actually add these decimals. You're still fine. You're definitely fine. And the upper is going to be okay. And let's confirm to confirm if that is
And that's it. So we don't have any other outlier in our data set. Now, if we do df, there might not be any outlier, but then there are still some, non values inside of there. And we're just going to check out the next thing that we have to do because we're definitely working with this. So we've cleaned this. Now we've clipped out. Now we're going to convert to numeric. Okay. So we've done this and we've done this. Now let us convert to numeric. Now how are we going to do that? How are we now going to do that? Now we're going to say df is equal to pd2 to numeric. Now, one of the things, one of the reasons why you need to understand this now is because you see that there could be something like maybe, sorry, oh God, I don't know how I clicked that wrong way. So there could be some, let me just have that data frame again. So I'm going to show you something. .tel, maybe 10. Now there could be something like, maybe in your data set, you have something like, for example, 23. Now, what's this? After converting to numeric, it's going to convert it to 23. Okay. So that's what I mean by converting to numeric. Okay. Yes. So now what I'm going to do now is df_pd to numeric. And now what are we going to pass now? We're going to pass. So we're going to just pass in some of the parameters that are very important to us. And what are actually some of those numerical variables then? We'll see df age, right? And maybe we can say errors equals to cos. Okay. And then automatically what this does is that it has now converted the age variable into what, to numeric. But I don't just want to do this for this alone. Why don't we just highlight all the numeric or the features for this and then pass it inside the list and do that. So we can say I could say column, maybe you could say numeric calls is equals to, I'll create a list and I could just fit them into that list. Let me just have df.columns so I can copy this data from here. Okay, so that's it. So I'm just going to create a for loop for num in numericals. So I'll say num calls call. Okay, I'm going to say num and that's it. So it should work. So automatically now it has converted all of this to numeric. And yeah, that's it. So is there any other thing that we are yet to do now? We're going to also do the same thing now for strings. Okay. Yeah, we're going to do the same thing for strings. And what do I mean by strings? Now, strings now is more like we have some kind of, here we have lowercase, we have uppercase starting. We have uppercase, we have none. None doesn't have anything to do with it anyway, but you see that there is inconsistency. Bauchi is upper. And all of these are actually very important because whenever we're performing our one hot encoding, we'll need to like have everything well aligned so that the machine is going to be able to have that well sorted out. So I'm just going to call these numeric features. I don't know why I already called it numeric calls. I could just do for one. I'm going to call it one hot calls. Oh no, I'm going to do for cat calls, and I'm just going to call that. So what's our categorical columns? And I'm just going to list all of them out. We have sex, positive, down till bed nets used. I'm just going to wrap all of them inside of this list. Is there any challenge? All right, so that's fine. So now there are actually a lot of ways we can do this. I can start to say df maybe sex. Now let's look at sex. We have male, female, and all of that. But I think there is something we are going to do to the sex column because more like it's how will I put it? When you look at the sex column now, right, you find out that it is, we have somebody that filled female, we have somebody that filled female as lowercase. Now we have somebody that filled female as uppercase. Now the computer is going to recognize this as different categories. It has different, feature properties or whatever thing you have in mind, or that you feel like you call this. But what we're going to do right now is that we're going to aggregate all of this into one, so that it's going to make a lot of sense when we are basically, trying to work on it. Do you understand? And so let's say for example now, look at the way the computer has represented this right here, and it's trying to show maybe somebody said male as M, somebody feel male, somebody might feel male as another thing. They are different at this point, okay? But I'm just going to show you how we can, sort that out. But before we actually do that for sex, so probably we might have to remove sex from here, because basically, and we still have some sort of unknown. We have unknown in hospital type. Yeah, because we need to check out our columns one by one for proper pre-processing. We have unknown in hospital type. Where else do we have a none? And okay, we have unknown in hospital type, so we'll still need to deal with that. And I'm just going to show you how we can, basically deal with that in a jiffy. And I think there was a loop where we looped. So we have unknown in temperature, sex, region, hospital type, hemoglobin, and lots of that. So we can actually just do something like this. You can say df dot describe, or dot, maybe you can say dot df random one, or you can say dot, maybe dot value. Now this is not really right, because you cannot do an indexing for something that is a string, okay? But if we change this to hospital type, also I think there's an error there, it's definitely going to work, okay? Now we need to deal with this. We need to deal with this unknown here, all right? So we need to deal with that. If not, we might end up having 4 categories and also rating our unknown, okay? So how do we deal with that now in all these problems now? Now the first thing we are going to do now is, first of all, let us watch what we are going to do for our sex. So we'll also do that to other categorical variables. For the numeric variables, it will be dealt with when we're going to be scaling that, okay? But for the categorical variables, it's very, 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 very important that we do what? That we deal with that, okay? It's very, very important. Else, it's going to make, we might have some kind of, we might have a lot of problems in our data set. So let's go. Now it's different from us having none. It's different from us having none. Okay, yeah, none is something different, or maybe none, maybe more like vacant, maybe changes all the none into NaN and all of that. But in this case now, we need to really, 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 really understand excuse me, how to deal with that. Now what we are going to do right now is, because we want to deal with that for respect to our sex as a category, what we can do is, let us convert all of this, okay, into lowercase now. So what we cannot do now is, we cannot see, okay, I'm just going to come down a bit. I'm going to see here, for call in cat calls, okay? Let's just deal with everything, and then I'm going to say df. Now, okay, probably if I want to do it, maybe for one or something, cat calls, and maybe probably you might just want to call it, maybe say df, and you continue to iterate inside of that. But I'm just going to say cat call, that's just one call.
call is going to be equals to df dot df call dot as type string dot strip, okay, string dot lower dot maybe probably what else are we gonna check? Okay, so we have the string dot strip, so to check out all of those. And I think that's going to be that. I don't think there's anything that we're missing out. Basically this is for calls, everything inside of the column. And I think that's gonna run. Now let's check out our data frame. What happens? Now you see that all of these are now in lowercase. Everything is now in what? Lowercase. Okay. There's none of our column now that is in what uppercase. We're seeing num. Where is num coming in from? Okay, that's a mistake. Num. Okay, so we can just restart our kernel. Okay. Okay, so we're just gonna check out those. Then we do this. And then we do this. We do this. Okay. Yes, and that's out. So we've taken that out, okay? And I think there's a problem there. We're having none. Just to sort that out, I'm just gonna check.
Okay, so we can just all right. So PD to numeric. So to handle that, then the next thing we're gonna do is so we have our so essentially we've handled that, So we'll standardize the text, and so we're going to create our pipeline. Okay, so we've done this as well. So next thing we're going to do now is to create our pipeline. Okay, so I'm just going to copy this so we can have a clearer guide on what we're doing. So the next thing we're going to do right now is we're going to now create our pipeline, and then have our numeric inputs, and one hot encoding and all of that. But before then, I think it's very, very important for us to understand that when you look at our sex category, there are still some discrepancies that we have there. Okay, we have stuff like none, we have male, we have none, and some of all these things apply in some of the numerical data, categorical data sets. Particularly, I don't know if we scaled some region. We could just check out that. We could do something like maybe df region dot value counts. Let's check out. Okay, do we have any unknown? Okay, we don't. And but for hospital type, we do have hospital type. We do have unknown of 18. So this is very important. Okay, for educational level, do we have none? For bed nesters, we don't. So what we would do now is we are going to do something now in this sex and hospital category. So what we're going to do now is very simple. So we're going to create a function. So I'm just going to call this function check, maybe check sex, or maybe probably can call it cleaned sex category, and instead of it will take x, and then the next thing we can now do now is I think basically that is just that. So it's going to return male, so we're going to return male, and return mp dot none. Okay, yeah, because it's easier for the computer to basically handle that. Oh, Alpha.
Hey, what's up?
I did.
You must say that one will be the main this thing now.
I know. That one I just forwarded my folder.
So they need to the group has to bring out a topic they're going to work on. You get?
Yeah.
So now we can. So but the main thing on the reflection, when it was submitted on 20th.
No. I did class now. I did class now. I
Okay,
go
great
back
class.
to
Okay, I'll call you later.
All right. Okay, so it's going to return mp.nan, and that's definitely how we're going to handle all of those parameters in another data set. Okay, and this is very, very important. One of the reasons why this is important is that you need to check your data very, 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 very well. Do you understand? Because we're now going to have df sex is going to now be equal to df dot map. Okay, so we're now mapping our cleaned sex. That should, and yeah, we've got that. Okay, so we're just going to restart the kernel so that
Okay, and then we'll have F and another. So if we do some value, beautiful. So we've got it. We've got it's male and female 266, and oh, I think there's nothing really we're missing out on, and maybe yeah. So if we've got none, yeah, we can just have a clear look. We can do something like we could just copy this, bring it in. So we have female, male, and none in the array. Okay, so this is the number of male and female and all of that. So we're going to do the same thing for hospital type. Okay, and now the first thing we'll do now is we're going to create a function. I'll call it cleaned hospital. And instead of the function, it's going to take in x, or maybe we can just give it y. Say if pd dot is an a in y, then return np dot none, and then say here we can now see that y is equals to string of y dot strip dot lower. That's it. If yn. Now before then, we might need to know what is inside of y. So we'll copy this and put it and say dot unique. So we have private, tertiary, and all of that. Okay. So what we can see now is if y in now, one of the things we can do here now is that it can be long. If you say if y in private, return private, then we'll now say maybe here and I say if y in this, I say return private. Okay. What we can do now is, instead of us to do this, okay, let's just complete it. Tertiary, right? Then the next one is if we will say if y in community return okay, then I say if y in return clinic, right? Then we'll now say return. Now let's see what happened. Then we'll now say return np dot none. Now there's also another thing we can do now. We can say here now df hospital now this might be a long sentence, but I'm going to show you how we can. Equals to df hospital okay, hospital type dot apply, and then we're now passing
clean the hospital. Now this is going to work because when we say df, when we say df hospital, now you see that you can't find that stuff again, right? But I think there can be another way. Instead of using this way, we can do something like if y not in, that means if the y, right, now instead of doing all these things, listing all these things like this, because we are trying to sort this unknown out, because if we leave this unknown here and pass it through the pipeline, you assign a value to it, the machine might think this belongs to something, okay? Or maybe when we do our one hot encoding. Now, but what we can do now, I feel like we can do this. So let me just save this, right? I'm just going to comment this out. And then so I'm just going to now I feel like what we can do here now is that we can say, okay, here yn, this is yn private, okay, because that's a list. So what we can do here now, instead of writing this long code here, we can just cut out this and so if y is not in this, so it means that y should be in this. Just return np.nan, and when we run that, let's see what happens. This we're just trying to check if that's going to run, and we're seeing np.nan, and that's it. You see, returns that, and but when we take out this, we comment this out. So we'll just restart the kernel. So excuse me. So now let's write for let's create a function. So we're going to call this function hospital. We're going to call it hospital, okay? It will take in parameter y, and we'll say if pd.isNow is star y, okay? And if there's anything like that, then it has to return. Let's check out something. So we're going to create a function, and name of this function is going to be hospital, and say it's going to pass token y. So if pd.isNor_y, then that means if there is if the on the data frame there is isNor_y with respect to this particular axis that is going to check, then it has to return np.num. Now again, now we can now see that what is this y? Y is equals to a string of y dot strip dot lower. Okay, then we'll now say here now that we're going to use a kind of nested if, not true, that just couple of if statements, chained if statement. So we'll say if y is inside of this list, where is the list? Okay, it should return private. If y is in this list that has tertiary, it should return tertiary. If y is in it should return community. If y is in clinic, it should return clinic. Okay, else let it return mp.none. Now we're gonna say df of hospital. All right, so that's it, and then we can now basically run all. Then we can now say, okay, now let us have so this is going to be df hospital type dot apply, then we'll now pass in hospital. Now let's find out df hospital type dot unique. So more like there is no longer none inside of there. Every other thing has been none. That's not a number, and that's very easy to handle. So essentially, we've done all this for our numeric, and we've done it for the female, we've done it for the male, and yeah. So I think we are good to go straight into our pipeline. So we're gonna check out the next line of action, and that's just basically to lift our pipeline. That's great. Oh, sorry. Okay. So the next thing is to perform our pipeline, right? Our pipeline scaling, and I think basically we just kind of highlighted that here, but we can continue. So what we're going to do now is, so we're going to say, okay, since we want to perform our pipeline, so what do we have to do? We're going to say, first of all, we're going to list out all our numerical variables. Then we'll list out all our, categorical variables. Then we're going to separate now. There's something we call, for us to scale our categorical variables. Now, our categorical variables have types. Now, I'm going to start by saying df.columns. Now, these are basically all the variables that we have here, right? We've got age, hemoglobin level, parasite density, temperature, sex, region, hospital type, educational level, bed net use, malaria positive. Okay. Now, what we are going to do right now is this. Okay, we're going to more of perform some kind of, okay, we'll say, okay, for our numerical features, there are, okay, which of them? We've got age, and I think I'm just going to mark that. Okay. All right. Then for our categorical categorical features. Okay, I'm just going to leave this for now. We're going to have, all of this. And now for our target, now we're going to have malaria positive, okay? Malaria positive. Now I want to explain something to you now. Now, when we come to our numerical variables, we are good with all of this. But then, unfortunately, if we want to kind of transform our categorical variables, right? Let's say, for example, we want to scale it. Right? We want to perform some kind of scaling in our categorical variable. Some of the features here have very high cardinality. What do you mean by high cardinality? When you look at our region here, we have about over 8 to 9 or thereabout, or over 10 like individual unique features that were entered by the participants, right? And for hospital type, not really so cardinal. We've got just a couple of them. Here we've got tertiary education. We have tertiary, private, community clinic. Okay, there is no order. And if you remember back in my session, I did explain my previous video that you can check out the video on my link of how we distinguish between categorical, numerical data types. Okay, we explained a lot of things about data types, and some of the things I was trying to just show there is that we've got some kind of, when we have numerical, categorical, right? Under numerical, we have continuous and discrete. Under categorical, we've got ordinal and nominal, right? And then now, when we want to perform one-hot encoding or encoding, when we want to encode our features, we have one-hot features, and we've got kind of target features, target labels, or say target labels, and we have more like normal labels, and also other ones that has some kind of depending on how you've got your categories. So, but I'm just going to explain that right here because we have we're going to divide our categorical into one-hot. I'm going to call it one-hot features. Okay, one-hot features, and for the one-hot features, I think a hospital type is going to be there. Bed use is going to be there. So we're going to put this as hospital type, and I'm just going to attach this as well. So these are what we call our one-hot features. So our one-hot features are going to be used for one-hot encoding, okay, in our dataset. So we're actually getting towards, we're looping towards the end. And now for region and educational level, now educational level has some kind of order, okay? I'm just going to do something right now. For targets is malaria, okay? This is, I don't need to wrap it in a list because it's just one series. So basically, I'm just going to come here and say for our ordinal features, so we have educational level, and this is going to be our target encoding features. So what we mean by target encoding feature, we're not talking about the normal target. Okay, we're talking about some of those features that have very high cardinality. Okay, and that's region. Okay, so it's very important so that it's not going to be explosive on your data. Okay. And the next thing we're going to do right now is I don't really think I have anything to do with this for now. We can just look at educational level one more time. I could just open a cell here. I could say df. Maybe I could just say educational level, if I'm correct. Dot unique. Okay. So essentially, what we have here now, we have primary, non-secondary, tertiary, and yeah. And now what's the order? So we can have something like we call educational order, educational. So I'm going to say we have none, so no education. We have primary, we have secondary, and we have maybe you can say tertiary. Okay, so this is also going to apply if we have ordinal features too that we are going to be working with. Okay, so maybe in our next class, definitely we're going to explain about these are actually very, very important information for you to take note of. So the next thing we are going to do right now is if you look at these parameters that we have, you could just scroll up a bit, and So what we can do now is we can say, okay, so let's create a pipeline, and what we're going to call this now is, maybe you can just call it pipeline is, because basically we just want to create a pipeline, and we can say we'll create an individual pipeline for all of these, okay? And then we'll start with our numerical pipeline. So we'll say numerical pipeline, and we'll call the pipeline method. And then we'll now pass in here, okay, basically what we pass was to we just want to scale our numerical features, and we can just because we're just setting up a pipeline, okay? It is just a pipeline, okay? And then we pass through our ColumnTransformers. Then we'll now say, okay, here we have our now do now is so it's very simple. We'll come to the next step. Our imputer is going to be simple imputer. Then for this particular one, we'll set the strategy as our median, okay? That's for the first one. And so inside of here is going to be because this is our numerical pipeline, so this is going to be maybe numerical. Yeah, I think that's going to be numerical pipe, and no, it's not going to be numerical, it's going to be scalar, and then I'm going to call this standard scalar. Okay, that's fine. So we move to the next one, the one hot pipeline, and we're going to go here now. The imputer is going to be the simple imputer, and then we'll pass on the strategy to be the most frequent. So what this does now is that it is going to handle those NaN, all those NaN values that are inside our data set, okay? All of those none, even if it's none, whatever thing it is. Remember here, somewhere here we declared, you know, I'm just going to show you something. So somewhere here now we added some kind of unknown parameters in our data set, okay? And yes, that's good for hospital type. And we did some messy stuff. Yeah. So now the next thing we'll do here now is that this is going to be one hot, and I'm going to say one hot encoder, and something ignore, because basically one hot encoder, and I'll just say ignore okay. So it is actually that for one hot encoder. Okay, now the next thing we're going to do right now is for our original pipeline. So if there is any unknown variable, it has to ignore that, okay? And then the next one is going to be our imputer, and then we have our for imputer or simple imputer, and as usual, strategy is going to be the most frequent, and ordinal, and then we're going to see ordinal encoder categories is going to be, so we'll pass in our educational order, okay? So the same thing also applies if we had another, let's say another educational, maybe another kind of ordinal variable or whatever, yada. Do you understand? We'll all pass it in here. Okay, we have to come in here and pass them in. Okay, so So for targets, what we're gonna do as usual, we're gonna say imputer, simply imputer strategy is going to be most frequent, and we have our target, then we have our CE dot target encoder. Okay, so that is that for our pipelines. Okay, so now the next thing we're going to do now is we're going to do some kind of pre-processing using our ColumnTransformer, and that is what we're going to do, pre-process. So that's going to be, so we're going to call our ColumnTransformer. I'm going to call the transformers. Now, for the norm, so it can be anything. So for the norm, it's going to be the numerical pipeline, then the numerical then we'll have the numerical features, then also we have 1 hot, so I could just say 1 hot. Then here I can now say okay, so this one is going to call it ordinal, so I could just use ordi, whichever one you can use. I can say ordinal pipeline, ordinal features, okay. So the next one is going to be target, so I could just use TGT, whichever one I can use, try to use big T, or I can use the small one. And I can see here, I could just put target. So this is more like we're looking at the target enc pipeline. Okay. And then also we're going to have target enc features. So this is our ColumnTransformer, okay? And yeah, everything is working really very well. We have now processed it, and now we want to train our model. So remember, we're looking at 2 models, the random forest and the logistic model. So we can do log model. Now is equals to, now we'll put it back in the pipeline again, but then this time we'll have our maybe we could call this prep, and call this pre-process, and then we'll have our classification model, and we'll call it logistic regression with a max iteration of maybe 1000. Now we can decide to fit this model, or we can decide not to fit it yet, but I'm just going to do the same thing for random forest model. I'm just going to put it there. I'm going to call it pipeline, and then pass it through there again, and I'm not fitting it yet. And we can basically print this model and look at how it's going to look like. I could just say here maybe prep and pre-process, and no, I'm just gonna, that's not a classification model, it's decision based model, random forest classifier. with n estimators of 200 and a random state of 43. Okay, now so this is it. Now our model is ready for at least cross validation. Okay, so we can perform cross validation. So we're going to run this, no issues. Saying pipeline is not defined. Pipeline. Okay, we think there was a wrong spelling somewhere. We're gonna check out that. Okay, this is it, and I think that's it. Okay, correct this as well. Pipeline is not defined again. Yeah. From Scikit-learn dot pipeline import pipeline. Education order is not defined. I think we have to run all the cells to be sure everything is running. Okay, shift enter, and that works very perfectly. So now for us to perform our cross validation, remember the formula for our cross validation. We have cross validate, contains our CVs, contains scoring, and maybe we can actually put return trend score and all of that. So what we are going to do now, what we want to do right now, that's going to make a lot of sense and make it very important, is that we'll say, okay, that for our CV, we're going to call the that's the SK strat, that's the stratified K fold, and then now inside of this, now we're going to have our end splits as 5. Our shuffle is going to be true, and I don't think maybe random states got the 67. That it works. Now this is just for this. Okay, now how about our scoring? What are we actually interested in? So we have to go back to what we defined here. We want our accuracy, then our F1 and our ROC. Okay, so we can just come to score. Excuse me. And inside of this scoring, we can say our scoring is equal to, now pass a dictionary, and we can just say, okay, our accuracy goes to our accuracy. We can equally do this in a list, and our F1 and our ROC. I'm going to call this ROC. I think that's all right. So that works very fine. So what we can now do now is results. So we're going to perform cross validation for logistic model. So this is our logistic model, and this is our random forest model. So what we can do now is we can now say for our log results. Now also it's also important for us to note that, which I'm definitely going to show us, there are also other parameters that are also brought out, okay, from this. But I'm just going to say logistic results is going to be now what's it going to be? We want to do our cross validation. Okay, that's our cross validation. So we'll do our cross validate. Then inside of it, we'll have our log model. So where is that? This is it. So we'll pass it in, and then have our CV is equals to our CV, which is this. Scoring is equals to scoring, and what else? And the next thing we might have is we also have our No, we can ask it to return the train score as true. Okay. Yeah, so these are actually basically the parameters that we need. And our cross validation returns 4 parameters. Now let's just print logistic results and see what it returns. Okay, sorry, we haven't fitted our X and Y. So to fit our X and Y, because we need to pass it inside of here, X and Y, our X, obviously, we know that it's going to be df dot drop, okay? And what is it dropping? It's going to drop columns of target. So what's our target? Malaria positive, right? So we can equally say malaria positive here, and okay, and then our Y is going to be df target. Oh, what's the problem? And then we're going to pass in our X, Y. Okay, all right, so we run our code, and sorry, there's a mistake. We need to bring our X and Y to the second part, and when we run that, nothing happens. Oh, I think there's a mistake. Okay, everything works really very well. Okay, and yeah, so I think we are quite in the mood, and the next we're going to do now is log result. Now, we want to print our logistic, basically what we want to do now, we want to present our logistic test accuracy and the train accuracy and the F1 and F1 score, the test F1 score and all of that. So what you need to know is that if we print log result, let's say for example, we print log results. Now, this is going to print out like a dictionary that contains 4 parameters: our fit time, the score time, the test accuracy, the train accuracy, test F1, the train F1, and the test ROC, and the train ROC as well. Okay. Now, for us to actually print this, now because we'll do this for our both our logistic regression and also do it for our random forest regression. So what we're going to do now is, so essentially we're going to say, okay, fine. I'm just going to put it in a dictionary, pd.data frame. So inside of this now, we'll have our log, our F1, maybe we might call this our, maybe we can say our train F1 score. So to confirm that, we can just okay, our train F1, that's going to be the results of our train F1. And we can just do the same. So we can call this our log validated summary. So these are our log validated summary, okay? And yeah, so this is our test. So we'll just copy this.
So this is going to be our train, our test accuracy, and test okay. So we'll call it our train accuracy. Now we're going to call this our train. Okay, we have our F1 already, and train ROC AUC, and this is going to be our train ROC. So this is also going to apply again, but this time this is our test. Okay. Now, so this is it now. So for us to now print our log validated summary, we can print our log validated summary, and it's going to be a dictionary. Okay, what's the issue? It's saying that name result is not defined. Okay, so this is going to be log results. Okay, I can just change that quickly. Okay, this is log results. So this is our data frame. Okay, now if I want to now print the mean of each of them, I can do that. So I'm just going to say, okay, let's get the mean of each validated logistic value. Okay, so I'm going to say, now for the mean of accuracy, so I'm going to print now the log validated summary for so more like this is going to be train accuracy now. Okay, train accuracy, to be sure. Yes, that's correct. Now dot mean. So we're going to do the same thing for the mean of the validated log train in the F1 score. Okay, and that's going to be the same thing, but this time it's going to be train F1. Same thing is also going to apply for the also going to apply the same thing for the we've done the accuracy training, and then we're going to do the same thing for the ROC. For the train ROC AUC, that's the receiver operating characteristics area under curve. So AUC. So that's just to change this to train ROC AUC. So you can start to still do the same thing for the test, and so when we run that, so this is actually the values that we've got. So if we want to maybe take it to 2 decimal places, we can do that to F. Maybe dot. Then we'll have. I could just wrap this and all of that. Okay, move it to decimal places, and that works fine. So yeah, so that's it. So now the next thing we'll do for the when we're going to perform the same thing for the random model. So I'm going to say the random model results. I think it's better to say RF results. So it's going to be cross validate. So call the method cross validate, and then we'll pass the RF model, and then we have our X, Y, then CV is equals to CV, scoring is equals to scoring, and then it has to return score because true. Okay, so what we're going to do right now is we're going to see
RF result summary is going to be equal to pd.positivity data frame. We pass a dictionary inside of that. We can see our test F1 is going to be our RF results. Okay, our train F1 is going to be our RF results train F1. Our test accuracy is going to be our RF results is going to be our RF result So now for us to print the mean of the RF, that's for our RF, maybe that's a random forest model train accuracy. So we could just say I was going to print train accuracy. So it's going to be our result summary, then we'll pass in our what? Train accuracy. Okay, so we want to get the mean. So we could also say, okay, let's print the mean of the RF model. Maybe it could be our train ROC AUC, and that's gonna be print the train ROC AUC. Okay, RF F1 score. Excuse me. That's going to be the RF result summary. Then it's loop over train F1 dot me, and we're gonna ask dot me, and it's gonna run, and yep. So that's it. So that's the train accuracy 1.0. That's 100% and all of that. So so that's actually that. So but then I think we can still do much more further. We can print the classification report. What I mean by the classification report, that gives us the accuracy of the model and other insights that we might want to know, maybe probably the confusion matrix as well. And yeah, so those are actually some parameters that we can still get out from our model. So I think maybe we might not have imported the confusion matrix. So from Scikit-learn dot model selection import, no, that's from metrics, import the confusion matrix. So the confusion matrix is not to make you confused, actually. It's just it's very useful in epidemiology. So now the next thing we might do now is since we have our x and y, so we can say our x string. We can say our x string, x test, y string, y test is equals to string test split of x, y. Then we pass our test size at 0.3, and we'll have a random state of maybe 45 or whatever. Now, what do we do now? Now, for us to actually get some information that we need, so we can actually say, okay, let us get into we have our log model, right? Dot fit. So fit it with the x string. Okay. Y string. Okay. Now, I'm sure we also imported our accuracy score, just to be sure. So this is what our model looks like, okay? And you see the pipeline, the ColumnTransformer, and then you see the this is for the numerical categories, and this is for the one hot categories, the ordinal, the target. Okay, so yeah, so that's actually a clear description of what our model looks like. Okay, yes. So now let us actually predict the accuracy of this model. Now to do that, we're going to actually say we can print it directly, but I just want to keep it very simple and easy. So I might want to get the pred. Remember, we're dealing with the logistic model, just so you know. Our pred is going to be the log model dot fit, okay, dot predict rather, okay, x test, okay. Now what it means is that now for our accuracy, we can now say we're going to print our accuracy. That's our logistic accuracy. I could just add that. Okay, so I could say logistic accuracy is going to be our accuracy score. So we call the method and we pass in our y test and our preds. So we print that. So it gives us 99% accuracy for our logistic model in predicting malaria, maybe malaria positive or malaria risk or whatever. Okay, complicated malaria. Now that is for that. Now I could also print maybe our classification report. Okay, so I could say print classification report, and then I'll pass in. Okay, let me spell out that reports. I'm gonna use an N. Okay. Classification reports. Then you have your what I'm passing in. We're passing in our y test. So automatically that gives us our classification report. We have our precision for our targets. It's basically makes the classification based on our target and our right. That's 0 and 1. How about if we want to see the confusion matrix? So I'm just going to do the same thing. Confusion matrix. Y test. So this is what your confusion matrix looks like. So I've made an explanation in the previous video. Now this stands for the more like the true negatives, right? So these are the people that don't have the disease and they are correctly identified to not have the disease. Now this is true negative, right? So this is the false negative. Now these are the people that were wrongly identified to not have the disease, and it's 0. Okay, and it's a very risky group. And here you can see that it's a very, 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 very good score. 0. So it means that after the testing, people were correctly identified not to have the disease. Okay, because if you have 1 here or 2, it means that 2 people have the disease, but it was classified that they are false negatives. So meaning that they are saying that
they don't have the disease, whereas they do what they have it. Now, this is what we call false positives, okay? Now, what do we mean by false positive? Now, these people don't have the disease, but they are being classified to have it, okay? And that's what we use in calculating mostly our precision, where we have our precision, our true negatives, true positives here. These are the people that were accurately classified to have the disease. And for our precision is usually gotten from our true positive over our true positive plus our true false positive, okay? I'm just going to write that down in the markdown so that you can understand that. True positives for our precision score is equal to, that's what was gotten here, it's equal to, now we'll say our true positive over our true positive plus false positive, whereas our recall score is denoted as our what? True negative all over our true negative. No, that's our recall score is going to be giving us our true positive all over our true negative plus our true positive. So yes, that's what our recall score. While our overall accuracy of the model is our true positive plus, I'm just looking for my plus our true negative all over our true negative plus true positive plus false negative plus false positive. I think that was false positive. I mistakenly typed the wrong. So I don't know what I was looking at. So this is our overall accuracy, and it's 0.99. Okay. When you do this mathematics with all of this, you're definitely going to get it. And you can see that our record score is definitely going to be 1. And that's it here. 1. Okay. So accuracy 0.99. When single-handedly calculated, it's still 0.99. And this is our confusion matrix. So this is a very, very important metric in epidemiology or in public health. Maybe you're trying to do any form of machine learning prediction. Confusion matrix is very, very important. Okay. It makes your model, it makes more clarity, particularly for classification-based models. That is that for our logistic model, and I think we can go ahead to save the model. Basically, we'll fitted the model here, and we can just go ahead to save it. I could just call this maybe x equals to whatever, then save it, and that's fine. But still, I could just go into our random forest classifier. Okay. Now, for our random forest classifier, I think what we are going to do is not really going to be different from what we've done. It's just going to be our RF model dot fit, then pass our X train, Y train. Okay, and we'll just take a look at that. And this is our random forest classifier, which is a tree-based model from the Assemble. It comes from the Assemble package. And now for us to do for us to work out some predictions there, we could say our, maybe you could say preds or R pred is equals to that, but then I can try to just make it more longer. And I could say, let's just go straight to printing the classification report to print our accuracy of the random model after being fitted. We could see our print, we call the print function. So accuracy of the random model is going to be denoted as accuracy score y test. Then inside of it we'll have our RF model dot predict x test. Okay, so okay, what's the problem? Service is not callable. Okay, let's check out RF model predict x test. Okay, so this is supposed to be y, comma, and that's it. So this is it, correct. To do for the classification report, I'm going to turn this to classification report of the random model. I'm just going to bite a semicolon here, and I'm going to change this method to classification report, and that's going to run. Okay, what is the issue now? Incomplete input. Inspection reports. Oh, I just want to know. Okay, there's a bracket missing. Okay, yeah, that's correct. So we'll do the same thing for our. We're going to do the same thing for our. So this time, I think we're going to call it our confusion matrix. And okay, and we'll call it. And that's it. So here we see that recall score is going to be slightly high. And you see what it means is that 2 people we have wrongly identified to not have a disease, whereas they do have it. And that's a very risky metric. So when we have tested this our model, and I feel like it performs more better using the logistic model. So that is going to be that for our session today. We started by creating our data set, making sure we set up a small messy data set as possible. We injected some duplicates, properly. We cleaned it, and just want to be sure that was done. And okay, and then we cleaned the duplicates. Then we also performed a lot of some kind of mathematical arithmetic inside of there, and yeah. So that's going to be that, ladies and gentlemen, for this particular session. So I'm going to drop this on my Git repository. If you're actually interested in getting started with machine learning, this is directly the time for you to do that. And yeah, so it just takes everything for you to get started. It requires some kind of discipline and yeah, everything that you really need for you to become a machine learning engineer. So I'm just going to say git add this, git commit initial, and yeah, so that's it. I've committed it locally. The next I'm going to push it to my GitHub. So I want to say a very big thank you for your time into this lecture. See you on the next one. Bye bye.